Right, so we've been talking about exponential growth a lot, and we're going to continue to do that. And today is going to be more of like solving the math equation version of that. So yesterday you guys did like some review over exponent rules. Like if you have a power to power, you multiply. If you multiply, you add the exponents, things like that. So we're going to use those. This will require a little bit more problem solving today, more so than like the graphing did. And you're gonna have to draw on some of your algebra skills a little bit today. So we're gonna be solving exponential equations. So if I were to write something like 5 to the x equals 5 to the third. All right. Can you guys solve that equation? Well, how would you solve the equation? What is it? X equals 3, right? Okay, very easy. So this is the principle we're going to use today. If 5 to the x equals 5 to the third, well then x has to equal 3, obviously, right? It seems pretty obvious, pretty basic, and that's what our rule is. It says if we have some number, we should say a to the u equals some number. Again, it's the same number though. A is the same, just like the 5s are the same. If a to the u equals a to the b, then what do you think the case is? What would be the conclusion? Exactly. All right, u equals b. So we're going to use this fact to solve all of our equations today. I kind of wrote it into 3 steps, if you will, if you like to write out steps. You don't have to write it out, though. It'll be pretty straightforward as we go. But what we're going to do is to solve these, the first thing we're going to have to do is write the equation with the same basis. These numbers always have to be the same. It doesn't work if these are not the same. If you had 5 to the x equals 3 to the 5th, that's not really going to help us because these numbers aren't the same, right? They got to be the same numbers. So the first thing that we're going to do, if it's not already the case, is we're going to write these with the same bases. So something that you might see would be 25 to the x equals, let's say, 5 to the 4th. So those aren't the same bases. But how could we write these at the same base? Anybody have an idea how we could do that?
Make it the same base.
Okay, how could we make it the same base?
25 divided by 5. I don't know.
Okay, so what's another way to write 25? 5 squared, that's the same thing, right? So say 5 squared to the x equals 5 to the 4th. Okay.
So x would be 2.
Yeah, exactly, right. Because then we'd use our exponent rules. This is a power to a power, right? Power to power, you multiply. So it'd be 5 to the 2x equals 5 to the 4th. So we did that? Okay. So after we wrote them with the same base, then we're just going to set the exponents equal to each other. So we got it at the same base. So now it would just be 2x equals 4. And then we simply just solve the equation. Last step. So then solving it, as someone said, actually 2. That way. 2. So that's the gist of what we're going to do today. We'll get a little bit harder than that, but this is the concept. We're going to take something, try to write it as the same base, do whatever exponent rules we need to do, set the exponents equal to each other and solve it. All right, so the rest of it's just going to be some examples to practice here. Okay, so easy one to start. 7 to the x equals 7 to the third. So we've seen this before. X equals 3, right? Okay, that's where the easy ones end. Next one, we've got 2 to the negative x equals 16. So we've got to change one of these bases. You could, I suppose, change either one that you wanted to. Generally, you want to choose the bigger number to change it to make it the same base as this. We need to make 16 as 2 to some power. Okay, yeah, 2 to the 4th. So we're just going to keep this one the same. And you can just really just like kind of experiment with your calculator. If you don't know that 2 to the 4th is 16, you can just try 2 to some different powers. You can just try, just try 2 to the 3rd, that's 8. Do 2 to the 4th, that's 16. So we're going to write it as 2 to the 4th because that's equivalent to 16. Now that we have the same base, we can set them equal to each other. It's the same. Then we got negative x equals 4. Divide both sides by negative 1. Get x equals negative 4. Alright, throw in a fraction here. 1/5 to the x equals 1/25. So which one do you want to rewrite? 1/25, yeah. Alright, so let's see if we can do that. We know we got to make it equal to 1/5, right? What would be equivalent? 1/5 to what power would equal 1/5? Yeah, if we just squared it, yeah. Because 1 squared is 1 and 5 squared is 25, right? So if we just square both of them, with it, so then just x equals 2. All right, next one, go ahead and see if you can do that one on your own there. So hopefully you wrote 4 as 2 squared, right? And then we're just going to set them equal to each other. 2x minus 1 is 2. Add over 2x equals 3. So x is 3. Did we go with that? You could also plug it in to check. If you plug 3/2 in here, there'd be 2 times 3/2, which would be 3. 3 minus 1 is 2. What's that?
You just add the 1 over to the 2.
Yeah, it's just solving this equation. Just +1 plus 1 divided by 2. All right, let's continue to get a little bit harder. Okay, 3 to the x cubed equals 9 to the x. So it should be pretty obvious which one we want to change, right? Want to change the 9? 3 squared? So we're going to keep 3 to the x cubed. And then 9 we'll want to write as 3 squared. I'm going to do this first step, but you could probably combine it into one step if you want to. I'm going to write it that way. 3 squared to the x. But then when we have a power to power, we have to multiply these. So it just becomes 3 to the x cubed equals 3 to the 2x. So now we got the same base, we can set those equal to each other. All right, well, what do we do from here? Divide by x, okay. That's a good thought. We're actually gonna do something not that. The reason why is if we would divide by x, we would be able to solve it. So we'd be able to solve it. The only thing is we're actually going to kind of lose, you lose a zero when you do this. We're going to lose one of our solutions. So it's the right idea, but we don't actually want to do that because then we lose out on one of our solutions. Because 0 is actually going to be a solution. If you look at this, because if you plug 0 into both of those, it would equal 1. So we can't actually do that, but it's the right idea. What we're actually going to do is get all of our x's to one side. So we're going to minus the 2x over instead of equal to 0. And then what would we do from here? Think about factoring maybe. Yeah, you can pull an x out and see how these both have an x, greatest common factor, pull out the x. And then we're left with x squared minus 2. You got to use all your algebra 2 skills here. And then this is, we use what's called the zero product property, which says that when you multiply these, if you get 0, you just set each one equal to 0. So we set x equal to 0, and then x squared minus 2 equal to 0. But he's still tracking? Emily? No? Okay. And then we add the 2 over and square root it, right? X squared equals 2. And then x is going to equal, now remember we need the plus and the minus square root. Plus and minus square root of 2. So we actually have 3 solutions here. X is 0 and x is plus and minus radical 2. It's kind of got amped up, you know, it's not. All right, let's try this one. Next one. So think about what we're going to do here. Is there a way that we can write 16 in terms of 8? 8 squared? 16, right? 8 times 2 is 16, right? Sorry. Someone will inevitably make that mistake, right? They'll write 8 squared. It's not the case. Yes. Don't do that. Okay, it would be 4 squared, but then could we write this as something with a 4? There is a solution. Yeah, the solution is to write these both in terms of 2. Because you could write this as a power of 2 and this as a power of 2. So let's think. 2 to what power is 8? Right, so if we write 8 as 2 to the third, and then I'm going to keep all this other stuff, negative x plus 14. And then what's 2 to what's 16? So 2 to the fourth would be x. So this one we gotta change both bases. So then we're gonna multiply. Now when you multiply this, you have to distribute the 3 to both of those. So it's going to become 2 to the negative 3x. What's 14 times 3? 42 equals 2 to the 4 times x is 4x. So now we're good because we got the same base and we can set the exponents to each other. So take the exponents, negative 3x plus 42 equals 4x. And we just solve it. So we'll add our 3 x's over there. 42 is 7x. And then divide by 7. X is 6. What's that? Zoning out is going to be the bane of your existence.
Barely 2 seconds, immediately lost.
Okay, sorry. Where are you lost? What step did you get lost? Okay. Alright. We'll just do 2 more, and then we'll stop. Last year. Okay, so take a second and think how you want to do this one. So which one do we want to change? Yep, change 27 there. So let's change this into 3 to what? 3 to the 3rd power gives us 27, yeah. So we're going to keep this one as 3 to the x squared minus 7 equals 27 is 3 to the 3rd to the 2x. Alright? So then we're going to multiply these exponents here. 3 to the x squared minus 7 will stay as is. We've got to do 3 times 2x, which is 3 to the 6x. Now we can set them equal to each other. X squared minus 7 equals 6x. Alright, what do we want to do here now?
Set it to 0, so
Yes.
6.
Good. Move the 6x over so that equals 0. X squared, and I'm going to write it in the order from 6x. I'm going to put that in the middle with you so that we can see how to factor it here. So I just subtracted the 6x over. All right, we got to factor this. Anytime you have an x squared with 3 terms, your factoring is going to look like there's 2 sets of parentheses. Remember to do that. We think what multiplies to give you this one, right? -7, and adds to give you this one. So what 2 numbers multiply to give us -7, add to give us -6? 7 and 1 are the only options, right? Those are the only factors of 7. It's got to be 7 and 1. So let's put this in x equals 1, x equals 7. And then you just got to think about your signs. And they got to multiply to give you a -7, so that means 1's got to be negative. -7 and a +1, right? Instead of adding -6. And then you set each of these equal to 0. X plus 1 equal to 0. X minus 7 equal to 0. And we solve them, so we subtract 1. X is -1. And x is +7. I think we'll end with that one. So those are both solutions, -1, +7.